The equation of the previous question will turn out to be x square plus y square plus 3x is equals to 0. And now if we look at the system, we find out the g first. What is g? Half coefficient of x, that is 3 by 2, and f, which is half coefficient of y, which is 0. So center of the circle is minus g comma minus f, that is center of the circle is minus 3 by 2 comma 0, and radius is nothing but g square, which is 9 by 4, plus f square, which is 0 square is 0, and plus 0. So radius turns out to be 3 by 2 because c is also 0. The constant term is also 0. So g square plus f square minus c under root of that is equals to 9 by 4, which is 3 by 2. So this represents that complex equation represents a circle with center as minus 3 comma 2 comma 0 and radius as 3 by 2. So if you plot this on an Argand plane, that equation will find that this will represent a circle with center as minus 3 comma minus 2, that is, this is the center of circle minus 3 comma minus 2, and since the radius is also 3 by 2, this distance is also 3 by 2, so this circle is going to touch the y-axis and pass this. So this is the circle which will represent in the Argand plane with radius as 3 by 2 and center as minus 3 by 2 comma 0. Now let us take up some more equations now, the complex equations. This is complex inequality to be solved. Now let us solve by taking z again as x plus iy. This is in terms of modulus. This inequality is in terms of modulus of complex number. Let us separate the real and imaginary part. When I put the value of x, it becomes 3x plus 3yi minus 4i is equals to 3x plus 3yi plus 2. Now I simply separate the real and imaginary part within the modulus. I get 3x plus I times 3y minus 4 modulus is equals to modulus of 3x plus 2 plus 3y. Applying the definition of modulus, I get under root of the square of real part, which is 3x, so 3x whole square is 9x square, plus whole square of imaginary part, which is 3y minus 4 whole square is equals to 3x plus 2 whole square plus 9y square under root. Squaring both sides, under root cancels and we open up the brackets, and when we simplify this equation, after simplifying, let's see what we get. When we simplify this equation, we get 9x square plus 9y square minus 24y plus 16 is equals to 9x square plus 12x plus 4 plus 9y square. Now when we simplify, what you see that 9x square and 9y square cancels out here. We get equation of a straight line in this case, which is, if we shift everything on the right hand side, we'll get 12x plus 24y is equals to minus 12 is equals to 0. So equation will turn out to be x plus 2y is equals to 1. So it represents an equation of a straight line, 2x plus 2y equals to 1. So the locus of this line is equation of a straight line, 2x plus 2y equals to 1. So this straight line, when we represent on Argand plane, and since it was inequality, so this inequality will continue. There is no need to put equality here. This will be less than equals to, less than equals to, less than equals to, less than equals to. So this will turn out to be less than equals to 1. Now, when we show this line on the number line, we'll see we're taking the point on the, where does it intersect the x-axis? It intersects the x-axis at, putting y0 at 1. So, intersecting the x-axis at point 1, and where does it intersect the y-axis? Put substitute x as 0, we get it intersects at 1 by 2. So 1 by 2 is here. This is 1 by 2. So this line is line passing through these 2 points. Points passing through point 1 comma 0 and 0 comma 1 by 2. Now we have shifted everything on the other side, so we find these points now. Now, does the origin satisfy this equation? We see that origin satisfies this equation. So, if we put x is 0 and y is 0, origin is only this below the line. We put x is 0 and y is 0, we find that it becomes 0. 0 is less than or equals to 1. It satisfies the equation. So, the region will be this region coming up here. And points on the line. Also on the points on the line will be the equation, because equality is there, so points on the line as well as this region will satisfy this equation. Okay? Oh, this is it. When I have shifted this to right hand side, this will become greater than or equal to 0. Children, this will become greater than or equal to 0. This will be greater than or equal to 0 because I have shifted this side, so we will find the points above this line satisfying this equation. So we will have all the points above this line satisfying this equation, not that. Not this one, because we have shifted everything on the right side. We have brought everything on the right, so this is greater than. We have shifted this everything here, so this is greater than 0. So greater than 1. So all points above. Origin does not satisfy this equation now, because I have put the value of x as 0 and y 0 becomes 0 is greater than or equals to 1. No. So this is the region which will be satisfying the equation. So locus of this point in the Argand plane will be represented by this equation. Now moving on to the last question, we have mod of z plus 1 equals to mod of z plus 2. So again, taking z as x plus iy, I simplify the equation. What do I get? I get modulus of x plus iy plus I is equals to modulus of x plus iy plus 2. Separating the real and imaginary part, I get x plus 1. Sorry, x plus I get x plus y plus 1 times I is equals to x plus 2 plus iy. Using the property of modulus, what do I get? I get x square plus y plus 1 whole square under root is equals to under root of x plus 2 whole square plus y square. I simplify both sides. What do I get? X square plus y square plus 2y plus 1 is equals to x square plus 4 plus 4x plus 4 plus y square. Again x square y square cancels out here, and I get the equation as 4x minus 2y is equals to minus plus 3 is equals to 0. So which again represents the equation of a straight line which can be plotted and shown, and all points on the line will represent the solution. Why? Because there is equality. There is no inequality here. Whereas in this case there was inequality being greater than or equals to 1. That is why this solution came up. Now let us do one sum on argument now. When you are given the equation in terms of argument of a complex number, if you are given argument of z minus 1 minus I is equals to pi by 4, putting z as x plus iy, we get argument of x plus iy minus 1 minus I is equals to pi by 4. Separating the real imaginary part here, we have argument of x minus 1 plus y minus 1 times I is equals to pi by 4. Now argument means tan of, it becomes the imaginary part upon real part, tan theta, that is tan of pi by 4 will be equals to imaginary part y minus 1 upon the real part x minus 1. Now you simplify this equation, will become 1 is equals to y minus 1 upon x minus 1. So finally we get x is equals to y, or x minus y is equals to 0. And this line, you know, is a line passing through origin. This line is a line passing through origin and equally inclined to both the axes, that is with angle as pi by 4. So this is a equation, this equation, complex equation represents a straight line passing through origin inclined with an angle of pi by 4 from the positive direction of the real axis. This is the representation of this equation in the Argand plane. Okay children?